Learned behavior of animals. The behavior of animals immediately after birth is determined by the inherited behaviors characteristic of the species. However, their environment is constantly changing, and animals learn to adapt to the new situations that arise through their personal experience. As a result of these experiences, in addition to inherited behaviors, learned behaviors are formed during the individual life of the animal. Unlike inherited behavior, these cannot be inherited by offspring. Inherited and learned behavioral elements combine to shape the characteristic behavior of mature individuals. Imprinting. The proportion of inherited and learned elements involved in the formation of behavior is very different for different animal species. For groups of animals at a higher level of evolution, learning plays an increasingly important role in adaptation. Some forms of behavior are tied to a certain stage of life. Imprinting is fundamental among them. Geese follow their parents immediately after hatching. If the eggs are hatched artificially, the goslings will follow the first moving creature they encounter. Bonding with their parents only develops in young animals that are a few hours old. Learning and imprinting the image of what to follow takes only a few minutes and remains for a lifetime. If artificially hatched goslings are kept in the dark for 2 to 3 days after hatching, after the sensitive period has passed, the learning process can no longer be formed. Prey acquisition behavior of predators. Some predators also have to learn the behavior of hunting prey at a young age. For example, if an adult ferret comes face to face with a hamster, it will bite through the nape of the neck of the prey animal in a single movement. This species' typical behavior cannot be observed in ferrets raised separately from birth and kept on raw meat. If the young animal brought up in this way is brought together with a hamster, the ferret will start playing with it without any offensive intention. When the ferret approaches, the hamster responds with defensive behavior, rising and biting. The hamster's behavior triggers the ferret's series of predatory movements typical of the species. After a short fight, the ferret kills the prey animal with a bite on the hamster's spine. A few similar occasions are enough for the bite to be accurate, and the sequence of movements becomes a definitive form of behavior. The ferret thus learns the hunting bite, but not by following the example of its parents or peers, but rather by the reaction of the prey animal. The behavioral elements of prey acquisition are present in the animal in an inherited form, but these are arranged in the appropriate order by the behavior of the prey animal. Most of the development of learned behaviors is not linked to a certain age, but can occur at any stage of the animal's life. One of the simplest forms of gaining experience is habituation. Through this, animals actually learn which stimuli not to respond to. Any sudden moving object or new stimulus triggers defensive behavior in the animal. If the animal does not become accustomed to these and cannot distinguish between dangerous and harmless stimuli, it could spend its whole life in constant flight. The animal becomes used to repeated stimuli from its environment, with neither good nor bad consequences, and after a while, it no longer responds to them at all. For example, if you place snails on a wooden board and wait for them to come out of their housing and begin to crawl, and then hit the board with a stick, the snails will retreat to their housing. By repeating this several times in a row, after a while, the snails no longer react to the noise and continue to crawl undisturbed. As a result of the repeated stimuli, the strength of the response decreases. Habituation is not fatigue because the animal only fails to respond to stimuli that are repeated many times and are indifferent. Habituation is very important in animal behavior because it saves them from the huge amount of indifferent stimuli from the environment. The conditioned reflex. The dog's mouth begins to salivate when it tastes food. This reaction is an inherited form of behavior, an unconditional reflex. During an experiment, an indifferent stimulus was simultaneously associated with the food stimulus. A bell was always rung during meals. By regularly repeating the association of the two stimuli, After a certain time, the dog's salivation started even at the sound of the bell. This reflex was not inherited, but was learned by the animal during the experiment. The basic condition for the development of the reflex is that the two stimuli affect the animal at the same time. Through conditioned reflexes, animals learn to associate stimuli from their natural environment, such as smell or creaking branches, with the approach of prey or enemies. Gaining experience through active action means more complicated learning. The essence of this is that animals acquire new forms of movement to satisfy their needs. A hungry cat was locked in a cage, and meat was placed outside the cage. If the cat pressed the handle on the floor with its nose or foot, the door opened immediately. Initially, the caged animal tried various methods to access the food, and eventually, an accidental push of the handle opened the cage. The first escape took a long time, but after repeating the attempt many times, the animal eventually learned to solve the task accurately and quickly using this trial and error method. A similar experiment was also performed with rats. During the experiments, the animals recognized effective orientational movements confirmed by access to food. Since the animals trained and controlled themselves in this scenario, the process is called operant learning. If regular reinforcement is not provided, the responses are slowly extinguished, and the learned behavior ceases. Among the learned behaviors of animals, the most complex is behavior based on insightful learning. This can be observed primarily in animals using tools. For example, a chimpanzee is able to shape its existing experiences into anticipatory behavior and use tools to its advantage. For instance, with the help of a tree branch, it can break open a termite's nest, then quickly pick up and lick off the termites clinging to the branch. When short boxes are strategically placed in front of the chimpanzee and tantalizing fruit is positioned just out of its grasp, an interesting behavior unfolds. Rather than resigning to frustration or simply giving up, the chimpanzee demonstrates cognitive flexibility and problem-solving skills. It systematically manipulates the boxes, stacking them in a manner that allows it to bridge the gap and access the desired fruit. This example underscores the remarkable capacity of animals, even in captive settings, to adapt and learn from their environment. It serves as a testament to the sophisticated cognitive abilities possessed by chimpanzees and other intelligent species, shedding light on the intricacies of their behavioral repertoire. Thank you for your attention.